Hello everyone. So, we are discussing the fast system. So, in last class we have discussed the fast one system, which is actually compression method, compression module, where we can measure the surface thickness and released surface thickness, and also we have discussed that second principle, which is fast 2, which is measures the bending characteristics. So, bending rigidity we can measure in that system, and this system fast 2, it is exactly same as that of Shirley stiffness tester. Now, we will start another method, which is next module, it is fast 3 system. In fast 3 system, which is extension meter, which measures the extensibility of fabric at different load condition. In addition to the extensibility, it also measures the shear rigidity by biased extension. The instrument is very simple, and the principle wise it is a simple. Here we measure the extensibility by standard load. We do not measure the increasing load condition. Some fixed load condition we measure the extensibility. It is capable of measuring the fabric extensibility in warp direction, that is, suppose this is the fabric, this is the length direction, warp direction, wave direction, and also in the bias direction. Bias direction, at different biased angle we can measure the extensibility, which will indirectly show the shear characteristics of fabric. The extensibility is measured at 3 different loads: at load 5 gram force per centimeter, which is known as E5, E20 at 20 gram force per centimeter, and E100, which is 100 gram force per centimeter. So, fabric extensibility, when it is combined with bending rigidity, which is used to calculate the formability of fabric, and the formability is a measure of fabric's ability to absorb the compression on its own plane without buckling. Suppose this is a fabric, we want to compress the fabric on its own plane without buckling, it will not buckle. That quality is known as the fabric formability, and which is calculated from the difference between E5 and E20. So, at the load 20 gram force per centimeter and at the load 5 gram force per centimeter, whatever extensibility we get, the difference is used to calculate the formability. E100 is a measure of fabric extensibility. So, that is the at 100 gram force per centimeter load, whatever value we get, that is expressed in terms of fabric extensibility. If the value is below say approximately 2%, then fabric will be difficult to extend during seam overfit. So, that actually will predict the sewability of fabric, and also E100 will actually give idea about the stretchability of the fabric at lower extension. So, this is the fixed jaw. Before loading we have the fabric dimension, and after loading is the fabric dimension, and that difference gives the fabric extension. It is a simple, by simple loading. Here we are not talking about the unloading, here we are not talking about the continuous increase in load. And first three system measure the shear rigidity also, and biased extension is converted to shear rigidity, which is directly related to the fabric looseness. So, that means, if in warp and weft, if they are loose enough, then the shear rigidity will be low. So, that means, they will simply there will be higher biased extension, okay, if the fabric shear rigidity is low. So, this is the way we express. So, this one is the at biased direction, it is neither the warp direction nor the wave direction, and the after applying certain load, the biased extension we can calculate. The shear rigidity below 30 Newton per meter, the fabric deforms so easily, it creates some problem. The problems will be, it may give problem in handling the problem, laying off during the stitching or during cutting operation, and sewing operation. If it is above, it is very high, above 80 Newton per meter, then the fabric can be difficult to overfit. Okay. So, during the stitching operation, this gives idea of the shear characteristics. And last method is that first 4, which measures the relaxation shrinkage and hygral expansion, RS and hygral expansion. So, here the relaxation shrinkage is mainly due to the recovery of fabric structure which got strained during manufacturing. So, when the fabric is relaxed, the type of actual relaxation, type of shrinkage, it gives idea about the relaxation shrinkage. Okay. And very high relaxation shrinkage results in problem of the size of the garment, okay, change the garment dimension and puckering, like a fabric warp and weft. When we stitch together in certain stitching point, if the warp relaxation shrinkage is higher than the weft, then it will actually show as seam puckering. So, that creates problem. We must measure the relaxation shrinkage. So, this is the test method for measurement of relaxation shrinkage and hygral expansion. So, the hygral expansion, it gives idea about the expansion or contraction of the fabric due to swelling or deswelling of hygroscopic fiber. The hygral expansion may result in seam puckering, fabric waviness, buckling, and overall poor garment appearance. So, we must measure the hygral expansion also. So, test here, it has got 3 distinct steps to complete the test. The protocol is that in step 1, the fabric specimen is first oven dried up to 0% moisture to measure its dry dimension L1. So, first it has been oven dried, brought up to 0% moisture, and dry dimension is measured, and in step 2 the fabric is soaked in water, and depending on the soiling and desoiling condition the fabric may get expanded or contracted. So, the dimension here it is L2, and third is that the specimen is dried again to measure the final dimension, which is dry dimension, it is L3. From this 3 parameters L1, L2, L3, that may be warp wise direction or may be wave wise direction. We can measure both warp and wave wise direction L1, L2, L3, and from there we can measure 2 parameters. One is relaxation shrinkage L1 minus L3 by L1 multiplied by 100. That means, the initial dry condition and final dry condition, the difference between that divided by initial dry condition. So, that shows the relaxation shrinkage, and hygral expansion is nothing but that the difference between L2 and L3 divided by L3. So, that gives the hygral expansion, and this is the diagram which shows here the fabric is in initial stage and whence it is dried, oven drying, and this is the stage 1 step. After step 1 we get the value L1, and once it is soaked it gets expanded. It always it may not expand. For this example it is expanded, it may contract. Okay. Here it is after soaking it has become, dimension has become L2 due to the swelling of the structure, and then after drying, re-drying, it has come back to L3. So, this L1 and L2, L3, this difference is it gives idea about the relaxation shrinkage once it is relaxed. So, after soaking and re-drying it has been relaxed, and it gives the whatever the shrinkage, it is L3 L1 minus L3, that is actual shrinkage. So, it gives idea about the relaxation shrinkage, and hygral expansion it is L2 and L3, this difference it is a hygral expansion. So, from these 2 parameter we can get idea about the shape of the fabric and appearance of the fabric after stitching. So, as we have seen the first, the principles, the 4 methods, this gives a very simple approach of measurement, unlike the Kawabata system, which is a relatively complex system, okay, complex measurement of system and complex interpretation system. And FAST, although it is a simple system, but its interpretation gives a very nice information. Okay. The FAST system automatically plots the appropriate values and joins the various plotted points together to form a fabric. Okay. So, FAST control chart or fabric FAST fingerprint. So, fabric FAST control chart and or fabric FAST fingerprint, they are same. So, which is unique to each particular fabric. So, every fabric will get different fingerprints. Okay. We have different fingerprints, each value in the fingerprint has separate scale showing a graphical representation of the range of value in the appropriate unit. So, for different hygral expansion, extensibility, formability. So, this they have their different units in one fingerprint or one FAST control chart, we get all the parameter together. Also, each scale contains one or more shaded zone. These shaded zones actually shows the the extreme point or defect point. If the fingerprint falls into one of this shaded zone, a potential problem with the particular aspects of fabric, actually fabric performance influenced by the property is indicated. So, that actually if the fingerprint comes within that shaded zone, that will give us the indication that there will be some problem in the fabric characteristics. Now, this is the typical fingerprint. Here first it is showing the relaxation shrinkage RS, RS1 and RS2. 1 indicates the warp direction and 2 indicates the wave direction. Similarly, hygral expansion HE1, HE2, and this shaded zone means there is some problem. If the relaxation shrinkage is very low, that will create a fusing or pleating problem, and sizing problem will be there if it is very high. So, that if the value is in between, that means the fabric will not have that much problem. That means higher relaxation shrinkage will create sizing problem, that means after the fabric is made, after the garment is made, that will change the total size of the fabric. Similarly, formability F1, F2, warp direction, wave direction, extensibility it is E100 and E102, that means warp direction extensibility and wave direction extensibility. So, if the extensibility is very low, that means overfeed there will be problem, overfeed molding there will be problem, and if the extensibility is very high, then there will be check matching problem during laying up. So, for automatic laying up process where the large number of layers are being laid on the of a fabric, and if the fabric is single color, then there is no problem, but if the fabric is check type fabric, then check matching problem will be there due to the higher extensibility. So, that depending on the extensibility value, we can predict the problem of check matching also. Similarly, bending rigidity, if the fabric bending rigidity is very low, okay, then we will have a problem of cutting related problem will be there, and B1 means bending rigidity of warp and B2 is bending rigidity of weft. Shear rigidity, you will have problem if the shear rigidity is low, then there will be laying up problem, and then if the shear rigidity is very high, then molding problem will be there. Okay. So, but shear rigidity, as it is clear that there is no warp and weft, because it is measured by in bias dimension, it is not measured like extensibility, it is a warp and weft direction. Here it is measured in bias direction, that is why shear rigidity it is only one direction. Similarly, thickness is we get thickness, surface thickness we get, release surface thickness we get. So, if there is a difference between surface thickness and release surface thickness, we can get the idea from that idea from this plot and weight mass per unit area. And in right side we get the unit like relaxation shrinkage, the unit is in percentage, hygral expansion in percentage, formability is unit, the extensibility in percentage, shear rigidity in Newton per meter, bending rigidity micronewton meter. So, in right side we will get all the related units of the parameters, which is shown in left side of the this chart. Now, I will show you a typical fingerprint. So, this is a typical fingerprint. From here we can get some idea, we can get idea looking at the fingerprint the what type of problem this fabric will have. So, we will have the problem of sizing problem, we will have check matching problem, this fabric will have, we will have different cutting problem. So, this when at a glance from the this fingerprint we can get idea about the what type of problem this fabric will have in further processing. So, this gives idea, we can take precautionary action on that. So, another plot, this is the plot which shows that fabric it is perfect, which will not give any problem during the process. So, our idea, this is ideal fabric we should get, but here if we see the thickness and this, there is one problem here, it shows a surface thickness, you see it is a lower value as compared to release surface thickness STR, which is very high. What does it show? It shows this fabric, it is the whatever finishes were there, this actually finishes went off during washing treatment. So, the finish, this gives idea, although the fabric is perfect in all the sense, but the finish which has been applied it is not perfect. Okay. So, from there we can get, so we will see, if we see earlier fabric, here also there is a problem of this release surface thickness. Okay. Now, we will start another process of measurement of fabric handle characteristics, which is the principle of fabric extraction, okay, and by nozzle extraction principle. So, fabric extraction principle here, it has been a common practice for many years, it is not a new principle. Okay. The useful technique in judgment of fabric handle, it is qualitative method, old technique among ladies, where the fabric, particularly scarf, is pulling out a scarf through the ring and judging the overall quality based on the resistance during the pulling out process. So, the fabric is being pulled through the ring and the resistance, the force required to pull is being judged, okay, and that gives the idea about the fabric handle characteristics, and thus this principle is used. It is a fabric extraction principle, it is qualitative. Okay. Outcome of the research work is that a circular fabric specimen which is 250 millimeter, 25 centimeter diameter fabric, its center point is held by a pin which is drawn through a cylindrical nozzle, okay, circular nozzle of highly polished steel. So, once it is drawn through the nozzle, the load, the force required to pull is measured. The force required to extract the fabric through the nozzle is measured. The sample is deformed under very complex yet low stress tensile, shear and bending, as well as the frictional characteristics. Okay. So, the fabric is deformed during during the extraction due to all this type of complex force, which is actually done during the handle of the fabric. While handling the fabric, we actually exert all these processes, all this type of forces. So, this is the technique here it is used. So, looking at the way fabrics are handled by consumer before they make a purchase decision, the fabric is deformed at various stress. Okay. It was actually first used by Pierce, then Kawabata and Postal, different groups they have attempted to measure the extraction force and correlate with the fabric handle characteristics, and this during this extraction the fabric is undergoing compression, bending, extension, friction, all these forces are actually coming into play. And this present approach, which is a simple and quick objective assessment of fabric fill, which is user friendly, anyone can handle, single test for a fabric fill value, we can get the fabric fill, entire fabric fill value by single test, unlike Kawabata or FAST, where we have to test a large number of testing, like in Kawabata 4 different modules and all these things. Here using a single test we can get idea about the fabric fill, real time plotting we can get, and wide range of fabrics can be tested here. Okay. And the simple, the approach is so simple, the instrument is so simple, even a unskilled shop floor level worker can handle. Now, let us see the animation here. So, here in this instrument, this is the nozzle. The nozzle is a very specially designed nozzle, where we measure the extraction force as well as the radial force. The force during the extraction, the force exerted by the fabric on the nozzle, the radial force, that also can be measured here, and the extraction force is measured by load cell 1. Here there is a load cell 1, and radial force is measured by other two load cell 2 and load cell 3, and fabric is actually pulled through this nozzle. Okay. Now, let us see, and there is a plot we can see, this is a fabric, circular fabric and holding at the center, and fabric is actually gripped with the this jaw, and now once we start, this crosshead will move up and the load will show. So, this is the crosshead is moving up, fabric is being extracted through the nozzle, and this is the load extraction curve. This is the extraction curve and these are the radial force. So, load cell 1, load cell 2, load cell 3. So, we get the plot, and using this plots, using this graphs, we can actually get the value of the fabric fill. And in our experiment, the research experiment which we have done, which shows very good correlation with the this fabric fill value which we obtained from the this instrument and with the subjective test. And the instrument is very cheap, small scale industries can afford. This is the nozzle, picture of the nozzle, and it is gripped at the center. So, it is a low complex stress is applied, which is non-linear in nature. This is the schematic diagram of the instrument, where it is a shaft, limit switch is there, load cell for the extraction force, load cell for radial forces, nozzle is there, okay, pin to hold the fabric. Okay. So, the purpose of this instrument is to measure the fabric fill objectively and eliminating the subjectivity completely. So, completely it eliminates the subjectivity. So, it does not actually depend on the perception of a person. To select the optimum fabric by comparing the fill. Suppose we have 10 fabrics of same variety, a fabric is actually a particular fabric is treated with 10 different finishes and we have to pick the best fabric, optimum fabric. So, from by testing the fabrics with this instrument, quickly we can select the optimum fabric. To check the fabric fill after chemical or mechanical treatment. So, suppose we want to test whether the particular mechanical treatment or chemical finish improves its fill characteristics, that we can check quickly. It is a quick assessment and it is user friendly. Single test of fabric fill value, we can get the fabric fill value with a single test, real time, this part we have already discussed, and different fabric nozzle, different nozzle material we can use, metal we can use, polymer we can use depending on the type of fabric and requirement, and different size of nozzle we can use, because for stiffer fabric we can use larger nozzle, for flexible fabric we can use smaller nozzle, like knitted fabric we can use smaller nozzle, and different operating speed we can use here. It is a cheap, even small scale industry can afford. Now, this is the graph we get, this is a typical graph, it is the extension graph. So, by extraction force graph and the radial force curves, and from this extension and radial curve we can get different parameters, like WE is the area under the curve for extension. So, extraction curve, so it is a WE, unloaded fabric across the orifice for extraction curve. So, that is the length in millimeter where there is no load is showing. Peak distance for extraction curve DE, peak height for extraction curve PE, area under the curve for radial direction WR, peak distance for radial curve is dr, peak height for radial curve PR. So, these are the parameters we can get from the extraction and radial curve. So, these are the curve. So, we get software will automatically record all this data. So, dr, de, pe, pr, a value without any load. So, these values will software will automatically collect, and area under the curve will automatically be calculated, and once we calculate we can get some regression equation using all these value, which is predetermined regression equation for fabric fill factor, which has been obtained based on large number of data, large number of fabric we have got the value. So, I will come back to that aspect. So, in our research what we have done in to study the tactile aspects, the fabric is actually treated with a finishing agent, with silicon finishing agent with different concentration level. So, this is the raw, means without any finish, and the concentration level 20 gram per liter, 40, 60, 80, and with the increase in finishing level, what we have observed, the extraction force reduces. That means, it shows the fabric becomes the softer, or it actually the force required to extract the fabric becomes the lower as the fabric surface becomes smoother. So, this gives an idea that the fabric, objectively we can test the fabric fill. Now, in study 2 what we have done, we have taken a denim fabric and that fabric is finished with a wide range of finishing. So, the yellow highlighted fabric, it is a raw fabric, a denim fabric, and the fabrics are treated with different type of wash. So, the raw was desize only and all this, like this number 8 is stone wash for 75 minutes, a very harsh wash. So, different types of washing treatments are given for same fabric, and these samples we have collected from a particular industry, and the mass per unit area are almost very close, the same fabric. These are due to the washing treatment, some changes are there, but otherwise it is we can consider it is there is no difference is there. And then the fabrics are tested with one is subjective assessment we have done, and then the fabric we have tested in the instrument for objective assessment. For subjective assessment what we have done, we have taken around 125 subject, 125 people are taken of different age group and both male and female, different profession level. We have taken these are the subjects we have taken, and the rating we have given 10 ratings were actually proposed, where 1 is very very soft and 10 being the harshest fabric. And what we have given, we have asked the judge to judge the fabric 10 different fabrics from 1 to 10, okay. At different level we have asked them to judge, and 123 assessors were there, and which shows the fabric, this fabric is fabric 10, which is unwashed fabric, which gives the maximum harshness, it is a 10 level, it is a harshest fabric, okay. And the softest quantity is the typically around 1, which is given by the sample 8. Sample 8 means the stone wash, very harsh treatment. So, that gives the idea about that unwashed untreated fabric gives the harshest fabric, and the stone wash gives the, and this trend is almost same, this trends are almost same for all the fabrics, all the this assessors, okay. So, they have given the assessment, and then what we have done, we have taken this same fabrics to the instrument, and we have measured the fabric fill factor. This is the using this regression equation, okay, and where this PE, WE, DR, PR, A, these values we have obtained from the extraction curve, extraction and radial curve, we have got these values. And what we have got, interestingly, we have got very good correlation, with subjective and calculated fill factor. Subjective assessment of fabric fill and calculated fill factor, we have got the correlation coefficient is around 0.977, we have got the correlation. It is actually the fabric fill factor, the value which we have actually proposed here, it is actually gauged in such a fashion, it is the value will actually lie between 0 to 10. Okay. So, it is basically it is between 1 to 10, within that range it is lying. So, and our the subjective assessment was also between 1 to 10. So, that is how we have got very good correlation. And also what we have tried, why this complex equation, can we actually use the peak extraction force, the peak value of the extraction force with the subjective assessment. We tried to get the correlation, but we found that this is not giving the good correlation. That means, it is not only the peak force which is important, in addition to the peak force there are other parameters which we can extract from the extraction and radial curve. So, this gives a fair idea about the performance of our instrument. So, we can claim that this method, although it is very simple, if we test the fabric properly, it will give us idea about the fabric feel. But the main drawback, main limitation of this instrument is that we cannot compare the values from two different type of fabrics. Here we can compare only of similar type of fabric, like one fabric, very thin and stiff fabric may give same extraction force with a little bit thicker and very flexible fabric. So, that is why it is recommended that this instrument, this principle is to be used when we actually try to compare the same fabric. Suppose the same fabric is treated with a large number of finishes, we want to judge which finish, we want to select the optimum finish. In that case, this equipment will give us very good result, very quick. So, in the soft floor, suppose for a particular fabric we are trying with the different types of softness treatment. So, we can give idea about the which softness treatment will give the best optimum value. Another use is that, suppose the fabric, the feel value, your buyer is using that, he cannot actually touch the fabric, but he can feel the fabric by knowing the feel factor. So, feel factor if it is known, so if it is matching with the given specimen, then one can get idea about your fabric which you have produced, the feel value which is actually as per the standard or specimen. So, we also tried the relationship between radial force and the extraction force. So, that we are getting a very good correlation. So, average radial force and average extraction force, that means it gives us a clue, we can also eliminate the radial force. We can, because it gives the almost very good correlation. So, radial force without measuring the radial force, only measuring the extraction force and get the giving the other values like the energy required to for extraction and the peak extraction force. So, we can get the fabric fill factor only from the extraction curve, and we will stop here. Okay, thank you for patient listening.